Section 1.4 is about solving absolute value equations. First, we're going to define what an absolute value is. It's a value of a number that is the distance from 0 on a number line. If I have a number line here, it's easy to see that the distance from 0 to 3 is 3 units. But if you go to the left, even though you're going in the negative direction, you're still traveling a distance of 3 units. So that leads us to this idea that if you take the absolute value of 3, you're talking 3. Absolute value of 3 is 3. But the absolute value of negative 3 is also 3, because it turns negative values and makes them positive because it talks about a distance. So absolute value of negative 2 is 2, and absolute value of 7 is still 7. That's how absolute values work. Absolute values also act like parentheses, as we'll see in this example down here. I'm going to take 1.4 plus, and I'm going to substitute a negative 3 in for the y. Now, some people might think that the absolute value takes all these minus signs and turns them to a plus. Well, that's not true. What it does do is act like parentheses, so I'm going to simplify inside. This will be negative 15 minus 7 is negative 22, but it still has an absolute value around it. Now we'll evaluate this. Absolute value of negative 22 is positive 22, plus 1.4 is 23.4. Here we're asked to solve this absolute value equation. Because this expression is inside absolute values, that would mean that the x minus 18 could be a positive number, and that would equal 5. But it also would mean that the x minus 18, its negative version, would also equal 5. Because remember, if you plugged all of this inside the absolute value and took its absolute value, that should also be a 5. Because of the nature of absolute values, the positive version of this expression and the negative version of this expression would be a distance of 5. So here's how you set it up. You drop the absolute values and use a positive version and a negative version. So we'll solve this for x. We'll add 18. So x equals 23. And we'll distribute this negative x plus 18 equals 5. And then we'll subtract 18. Negative x equals negative 13. And then divide both sides by negative 1. So x equals positive 13. So there's two answers here. Put those in squiggly brackets, 13 and 23. And if you go back and plug them in, you'll notice that whichever one of those numbers you plug in for x, you will still get a positive 5. Here's an absolute value equation, but this time it has a plus 9 on the same side with the absolute value. We would prefer to get that 9 on the other side so that we can isolate the absolute value and then remove it using the positive and negative we learned in the last slide. But if you understand absolute values, this one is very, very simple, because the question to ask yourself, can you have a distance, and that's what absolute values represents, can you have a distance that equals a negative? And the answer is no, you can't. You can never have an absolute value that equals a negative number. Therefore, we'll say the solution to this is no solution. Because there's nothing I can plug into x whereby I'm going to take the absolute value and get a negative number, because absolute values produce positive results. And for our last one, we have a slightly more complicated absolute value equation. Because of the absolute values, we know that we could make this positive 8 plus 6 equals 3x minus 2, or we could say the negative version of 8 plus 6 equals 3x minus 2. Now there is another way to set this up, and I'll write it up here kind of on the side so you can see it. Here's the other way to set this up. You have the same two equations except for you put the negative with the 3x minus 2. It works either way, again, because of the negative version of absolute values becoming positive. You could set it up this way or this way, it won't matter. So over here we're going to solve, subtracting x. 6 equals 2x minus 2. Finishing up. X equals 4. On this side, I'm going to choose to do this a little differently. I'm going to divide by negative 1. Canceling over here, x plus 6 equals negative 3x plus 2. It's just another way to deal with the negative other than distributing. I'm then going to collect the like terms on separate sides, and I'm going to subtract the 6. If you don't mind me doing that, I'm going to have 4x equals negative 4, and then divide by 4. So two solutions, negative 1 and 4. So I can plug either one of those values in for the x's up here, and it will be a true equation.